Hello class, welcome to Unit 3, Video 3. Today we're going to look at solving systems of inequalities. So we have been solving systems but of equations. Now we have inequalities. So your learning target for today is that you can solve systems of inequalities, and we're going to do so by graphing. So let's go ahead and look at an example. During one heartbeat, blood pressure reaches a maximum pressure and a minimum pressure, which are measured in millimeters of mercury. It is expressed as a maximum over the minimum, for example, 120 over 80. Normal blood pressure for people under 40 ranges from 100 to 140 for the maximum and from 60 to 90 for the minimum. It says express this as a set of inequalities. Okay, well, I am going to let which one is this? This is my maximum. So I'm going to let the maximum be represented by the variable x. And I'm going to let the minimum be represented by the variable y. Okay, so what this means is my maximum is x. It is going to be from 100 to 140. So x has to be greater than or equal to 100. And x has to be less than or equal to 140. That's for the normal maximum. If I want to express the minimum, my minimum must be greater than or equal to 60, or it must be less than or equal to 90. Okay. If I were to graph this, x equals equations, remember, are vertical lines. So vertical lines they go up and down. So my x, these are lines that go up and down, and my y equations are horizontal lines, so they go from left to right like the horizon. So here it is graphed. Okay, so my maximum pressure is 100 to 140, so here it is graphed. So x is greater than, so I would shade in this direction to be greater than for this function here. And then if x is less than 140, you would shade less than 140. Does everybody see that in between here is where I would have double shaded? Okay, so that's where I have double shaded. So we're just going to look at that. Now we're talking about the minimum. It's from 60 to 90. Well, in this case, my y values are less than or equal to, are greater than or equal to 60. So to be greater than or equal to 60, I'm going this direction. And my top value is that y is less than or equal to 90. So here's 90. To be less than or equal to 90, I'd be here. Once again, notice how in between here is where I am double shaded. Okay, so if I do that, you'll see that where I got shaded all 4 times is just this centerpiece. So for this system of inequalities, this would be my solution. So we're going to be doing that today. On our notes, we're going to be graphing inequalities like that. So Classy Catering needs at least 15 food servers and 5 bussers to cater a large party. In order to make a profit, they can have no more than 34 servers and 7 bussers working at an event. Write a system of inequalities that represents this. So when we're talking about real life problems, I would recommend writing out what everything means. So B, I'm going to let be the number of bussers, and S will equal the number of servers. So we need to write inequality. So they can have no more than 34 food servers. So if I'm talking about my servers, they have to be no more, well, they have to be less than or equal to 34. Okay. The other thing it says you can have no more than 7 bussers. So my bussers has to be less than or equal to 7. And up top here, Classy Catering needs at least 15 food servers. So if I need at least, I need 15 or more food servers. So my servers has to also be greater than or equal to 15. And 5 bussers. So my bussers has to be greater than or equal to 5. So this would be my system of equations to represent this. Okay. If you have any questions, let me know. It doesn't matter what order you wrote them in. If I would have wrote, the way I was taught, the way I did it, this is fine too. Any order is fine. Okay, I can, as long as they're all there, that's what's important. All right, so we're going to Graph example 2. So solve the system of equations by graphing. So remember, you graph it as is and then you shade. This one, it's going to be a solid line because it's an equal to. Okay, remember if it's greater than or less than, it's a dashed line. If it's greater than or equal to or less than or equal to, it's a solid line. So this one, I'm going to start with my y-intercept of 4. And then my slope is -2, so down 2 to the right 1. And like I've said before, I recommend doing it all the way across the graph. And so, that didn't stay. All right, so there's that one graph. Now I'm going to go ahead and graph the next one. I would have -2 and my slope is 1, so I'm going up 1 over 1. This one is also going to be a solid line because it's equal to. Now I have to go ahead and shade. This one says y is greater than or equal to -2x plus 4. So I did that one in purple. To be greater than, I think shade above, but remember, if you're not sure, you can check a point. So I would plug in 0, 0. So 0 is at greater than or equal to -2 times 0 plus 4. This would be 0. Is 0 greater than or equal to 4? That is false, so I do not want to shade where here is. I want to shade on my other side of my line, which I would also think of as the greater side. For the other one, this one says less than. So right away, if I look at this line to be less than, I would think below. So I'm thinking I'm going to shade down here, but once again, I can check my point. 0, 0. Is 0 less than or equal to 0 minus 2? Is 0 less than or equal to -2? No, 0 is bigger than -2, so I do not want to shade here. Once again, I'm going to shade this way. And once again, my solution is where it is double shaded. On your test or quiz, please make sure you are clearly showing me which one is your solution. If I can't tell that that's where it's double shaded or that's what you want, I'm going to have to take off points. So please make sure you're being clear about where the solution is. Okay, example 3 has an absolute value in it. So remember when we solved our absolute value equations, we would just take it and we would say, well, y is less than 3. This is a less than, so it's an and statement. And y is, remember we flipped the sign and set it equal to the negative value. So it was less than, so now it's greater than. It was a +3, so now it's a -3. So I need to graph both of these lines. Remember, y equals equations are horizontal lines. And it's where y is always equal to 3. These are going to be dashed lines, okay, because there's no equal to. So at +3, dashed line, and at -3, dashed line. 1, 2, 3. Now let's talk about which way I need to shade. Y is less than 3. To be less than 3, I'd be down here. Once again, if you wanted to check 0, 0, is 0 less than 3? Yes, so I would shade where my point 0, 0 is. And this one, y is greater than -3, so I'm going to be shading above. So in between here is where it's going to be shaded. Then I just need to go ahead and graph my last line. That one's going to be a solid line. So I have -1, and my y-intercept, and my slope is 1, so up 1 over 1. And that's a solid line. So there is that, and y is greater than. So I always think to shade above. Once again, if you don't know, I'm going to check that point 0, 0. So is 0 greater than or equal to 0 minus 1? Is 0 greater than or equal to -1? That is true, so I do want to shade where that point is. And I would be shading all of it, but I'm actually just going to shade where my solution is, because this is the part that's above, and it's all where it's double shaded. So my solution is right here. And I'm going to indicate that, darken it, make sure it's clear. This is my solution for example 3. If you have any questions, please let me know. Otherwise, we're going to go ahead and move on and graph number 4. So we're going to solve it. The first one, notice, is a less than, so it's a dashed line. And my y-intercept is 4. So my slope is 1, 4. So up 1 over 4. Or I can do down 1 over 4. I recommend filling the entire grid when you are graphing. So Let's go ahead, graph this line. Okay, there's that one dashed. Now we're going to go ahead and do solid. This one has a y-intercept of -2. Sorry, let's go back and let's finish graphing this one here. So in order to graph this one, it's y is less than, so I would think shade below, but I can check my point 0, 0. Is 0 less than 1/4 times 0 plus 4? Is 0 less than 4? 0 is less than 4, so yes, I'm going to be shading below. Moving on to my other line, this one's going to have a solid line because it's equal to. I'm at -2, and I'm going to graph my slope of 1/4. So I'm going up 1/4, and down 1 to the left 4, same thing. One thing I would notice is these lines should be parallel because they have the same slope. And I'm going to have a solid line for this one. Okay, so there is that one. And this one says y is greater than or equal to 4. Or sorry, it's greater than or equal to 1/4 x minus 2. So to be greater, I'm thinking I'm going to shade above, but once again, I'm going to go ahead, check my point in case I don't know. Check in 0, 0. Plug it in 0 for x, plug it in 0 for y. So is 0 greater than or equal to -2? It is greater, so I would shade where this point is, and I could shade all of it, but I'm only going to shade where my solution is. It's in between the two lines. So my solution is there in the red. Example 5 looks a little different, not in slope-intercept form. So you can use the intercepts or you can go ahead and solve for slope-intercept form. I think it's easiest to put into slope-intercept form, so I'm going to go ahead and do that. So I'm going to subtract x to the other side. So I have -y is less than or equal to -x minus 1. And then to get y by itself, I would divide everything by -1. Remember, when you divide by a negative, the sign needs to flip. Okay, so I'm going to graph this. So my y-intercept is 1. And my slope is 1, so up 1 over 1, up 1 over 1. Or down 1 over 1, down 1. Okay, this one's going to be a solid line. Right there. And then it says y is less than. So I'm thinking I'm going to be shading below, but I can check my point 0, 0. Is 0 less than 1 or equal to 1? Yes, it is. Oh, I messed up on this one. What did I do wrong? I started my y-intercept at -1. My y-intercept, hopefully you caught that, my y-intercept is at +1. So let's fix that. Or let's just, I can move my line up too, but let's just delete it really quickly. All right, so y-intercept is 1. Sorry about that. I started out at the wrong spot. And there is my slope, up 1 over 1, up 1 to the right 1. And then my line. There's my line. And so yes, I would think to shade below. So this is good to do because look at how I caught that I made a mistake. So it is true at this point, and I was thinking to shade below, so there I am shading below. Moving on to my other one, going to do the same thing and solve. So I would have -y is less than or equal to -3x plus 4. Divide by -1. Remember, when I divide everything by -1, that sign flips, so it's greater than or equal to 3x minus 4. My y-intercept, -4. And my slope is 3 over 1, so I'm going up 3 over 1, up 3 over 1, up 3 over 1. Okay. Okay, there's that. And then it says y is greater. So I think I'm going to shade above. This one's a little bit harder to tell which one is the above, so I'm going to check my point, 0, 0. Is 0 less than or equal to 3 times 0 minus 4? So is 0 greater than or equal to -4? Yes, it is. So I would shade above, which would be all of this area here, but I'm just going to once again shade my solution. So my solution is listed right there. Okay. Any questions on example 5? Please let me know. Otherwise, we're going to move on to our last example, example 6. A little bit different. It says, find the coordinates of the vertices of the figure formed by the system of inequalities. So this time there is 3. The first one is going to be a dashed line. And one thing that you should be careful of is they have the y-intercept and slope mixed around. So my y-intercept for this one is 3. And my slope is really -1, so it's down 1 to the right 1, down 1 to the right 1. And this is a dashed line. Okay, so there is that one. Moving on to my next one, this one's going to be a solid line. And it's a y equation. So remember, y is your horizontal line, so y is equal to -1. The other way you could say is, well, where is y equal to -1? It's equal to -1 here. It's equal to -1 here, 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 everywhere along this line. Okay, so that one is a solid line. Okay. And let's go ahead and graph the last one. X is greater than -1. So that one's going to be a horizontal line, and it's where x is always equal to -1, and this is going to be dashed when I do it. So where is my x -1? X is -1 here, and all the way along this line. Okay, so it's a dashed line, so I'm going to go ahead and draw that one in. And then we just need to talk about where to shade for each one. Okay, so for this line, y is less than. So I'm thinking I'm going to be shading below, but let's check our ordered pair 0, 0 and see if it works. Is 0 less than 3 minus 0? Is 0 less than 3? Yes, it is. So I'm going to be shading where this ordered pair is. So I would be shading this entire area. I'm just going to draw some arrows right now to show which way I would shade so it doesn't get so messy. The next one is y is greater than or equal to -1. Well, here's my y. To be bigger than -1, I'm going to be going up. So we're shading this way. And lastly, for my x equation, x is greater than -1, so to be greater than, I'm going to the right. So once again, if I look, I'm shading here and up and to the right, so it's going to be here as my solution. So what is the shape formed? It is a triangle. And I need to list my vertices of it, so each ordered pair. So right here, it looks like I have -1, -1. Here, I have the ordered pair 1, 2, 3, 4, -1. And the last one, it's going to be -1, 4. Yes, -1, 4. So those are my vertices for my system of equations. Right, that's the end of Unit 3, Video 3. If you have any questions, please let me know. Otherwise, have a great day. Talk to you later.